Actually, when you presented at Durham University Business School, I think it was the actual day, or it was the day the press release came out. It was all to do with quantum computing.
Yeah.
And I could tell a story, but you could tell it much better. But then it's almost the doors that this could unlock. So I'm sure there's been some developments in the past 9 months. But almost, how would you like to describe almost Google's approach to quantum computing and what it now opens up?
Well, let's start with decoding it. It's quantum computing. What is it? So traditional computing essentially is ones and zeros done really quickly, right? Everything that we're doing, the Zoom application that we're on at the moment is just ones and zeros processed fast, turned into an application. And there's a thing called Moore's law. So there's a fellow called Moore who predicted back in the 60s that the processing power would double and the cost of that processing would halve every year. And that has been the case, ever since. That's an exponential curve. That curve, however, is starting to flatten. We've reached such a state of advancement and miniaturization and processing power that we're approaching the boundaries of physics in terms of heat and in terms of miniaturization. Yet we have these massively powerful computers today. This is why machine learning, right, is possible in a practical sense. We've got these applications like translation and spam filters and navigation and all of these things that we kind of take for granted as petabytes and petabytes of information processed really quickly. So traditional computing's very helpful. However, that curve is flattening. Quantum computing then takes the next step. It goes below the physical or around the physical barriers and takes advantage of a quantum principle called superposition. And superposition is a quantum state where a particle can be, I'll use the computing term, a 1, a 0, or some sort of combination. And it turns out if you have those possibilities and start putting these quantum units called qubits together, again, you exponentially expand processing power. So Google, as well as many other teams around the world, both private and academic institutions and government, have been working on this thing called quantum computing. It's really hard to do. It needs to be contained in a supercooled cylinder. And it's a very sort of brittle state that you need to achieve in order to make it work. And we had a bit of a breakthrough with our quantum team, I think it was October last year, where we had a little quantum computer with not so many qubits. I can't remember. I think it was 56 maybe. I can't remember exactly. Qubits, which did a mathematical calculation in 200 seconds that would have taken the most powerful supercomputer available today using the traditional 1 and 0 thing 10,000 years. So 200 seconds versus 10,000 years gives you a sense of the scale of progression there. This was a controlled environment experiment with a difficult sort of cryptography mathematical equation. So it's not quite at that stage where it can be applied with practical force.
But as a proof of concept.
But we're on that track, right? And what that means in real terms, right? This is not just about engineering, it's about the so what, is that we can start to do things like model climate, which is, natural processes which are incredibly complex, and develop much better battery technology and conquer some of the imponderables of medicine. Work on really hard diseases and problems like Alzheimer's. So, big things ahead, I think, and lots of positive applications for quantum computing.
No, I completely agree. And because I'm a mechanical engineer myself, almost it could even open up things like fusion energy. It's the ability to control things very, very quick. That actually, you can almost imagine a whole new step forward in terms of science, technology, and that kind of thing, which is just leaps, probably similar to what they were in the 1960s, but just again, which I think is quite fascinating.